Good morning, everybody. My name is Dick van der Wateren. I'm the EGU press officer, and I welcome you to this first press conference of this year's General Assembly of the European Geosciences Union. I want to hand over to my colleague Albert Gerdes from Marum in Germany. Please, Albert, introduce your guest.
Thank you, Dick. Thank you very much. Good morning, everybody. Welcome to this first of two IODP-related media conferences. IODP stands for Integrated Ocean Drilling Program. And we have another media conference on the results of the Great Barrier Reef expedition, which was held last year, which will take place at 2 o'clock. So this is about scientific ocean drilling, which started about 45 years ago. And the current program is the IODP, the Integrated Ocean Drilling Program. It's a 10-year program which started 2003 and will end, of course, in 2013. And since, say, 1.5 years, the scientific community has been discussing the question, what comes next? And the colleagues on the podium will hopefully tell you a little bit about what comes next. What is the next phase of integrated ocean drilling? I would like to introduce to you Catherine Mevel. She is director of the EGU Managing Agency in Paris. And I have to explain EGU because EGU is the European part of the Integrated Ocean Drilling Program. EGU stands for European Consortium for Ocean Research Drilling. Is that correct?
It's correct.
Thank you. There are so many acronyms around.
But I would like to add that EGU is a consortium of 16 European countries plus Canada. So Canada is sort of part of Europe for us.
So we integrate, it's an integrated program, so we integrated Canada. So Catherine is from EGU in Paris, and Kiyoshi Suyehiro is from Tokyo. He is the president of the Integrated Ocean Drilling Program, and he will start with his presentation. Kiyoshi.
Thank you.
Oh yes, the microphone.
Yes. Thank you, Albert. I'm going to introduce you to the new science plan about to be published. We're planning to publish the plan next month. We are really in the final stage of editing the contents. And we are talking about the next 10 years science plan, as this slide shows. And as Albert told you, there was a meeting in Bremen, international meeting in Bremen, which attracted around 600 participants from all over the world. And since then, many scientists have gathered together to write the science plan. So I'm going to very briefly introduce you to what's in this plan. And I will let you know the website address where you can see the most recent version. It has 4 themes. IODP spans a wide spectrum of sciences, as you can see in these 4 major themes that the scientists have identified as important for basic research and also important for the society. IODP is unique in that it internationally utilizes 3 different ocean drilling platforms, as you can see in this photo, that complement each other in drilling different environments in the oceans, oceans that cover 71% of our planet. EGU offers means to recover samples from shallow waters or ice-covered waters, as you can see at the right, in the center. And the Japanese CHIKU on the left side is for accessing deep depths. And the US JOIDES resolution on the right obtains cores from down to a few hundred to a maximum of about 2 kilometers beneath the seafloor in deep waters. So quickly going over these 4 themes, we believe that IODP can contribute to climate change problems by providing accurate records of the past history to reduce the uncertainties in prediction of our future. Second, the existence of deep microorganisms beneath the seafloor, not connected to photosynthesis, is an exciting world of discovery, and it's really getting bigger in the present IODP. And in the next 10 years, we will try to answer questions such as how do these microorganisms fit in the evolution of life, or asking whether they are our origin or not. The third, the plate tectonics, which you must know very well, is part of the mantle convection that comprises more than 80% of the volume of our planet. Deep drilling will open a new door in connecting the interior and the surface of the Earth where we live. And the fourth one, Earth operates sometimes very rapidly with great consequences, such as earthquakes and tsunamis. And what is the mechanism behind these events? We are yet to answer. And we believe boreholes beneath the oceans provide unique opportunities for long-term and real-time monitoring of the accumulating energy inside the Earth, and that suddenly burst out very rapidly. So I will go over each of these themes and just simply taking a few examples to show you the taste of the plan we are having in front of us. How the sea level change occurs is a great concern of the society. You must know how ice sheets behave, how corals respond, how ocean circulation changes, and these call for sampling history and processes at high and low latitudes, and that's what this figure is showing. And there are other questions, including how CO2 and climate change correspond, and also acidifications, its consequence, and how regional climate changed in the past, like monsoon and El Nino. Second theme is about the biosphere, and I mentioned about the microorganisms, but this figure here shows another exciting topic of understanding how we humans evolved in relation to environmental change, and we believe that IODP can contribute in this respect. The third is going into the interior of the Earth, and this is the left figure shows penetrating the oceanic crust and accessing the mantle for the first time in 50 years. I say 50 years because 50 years ago there was a project called Mohole, which attempted to drill into the mantle, and we are yet to attain that target quite yet. And so in the new science plan, we are going to target this. So we are now preparing ourselves to get into the mantle within the next decade. The fourth theme is about human timescale changes. Boreholes can be utilized as observatories, and observatories can be networked, like in this figure, which is offshore central Japan. And the red line shows the cable which connects to the borehole observatories. And as you may know, this kind of observational network is given on land, but it's not at all so in the oceans. So scientists would like to emplace various sensors in these boreholes to monitor ongoing processes and understand human timescale events like landslides, earthquakes, volcanoes, and tsunamis. And finally, on this figure, I would like to state that all these four themes are interconnected, and we believe it is quite important that we try to understand the Earth as a system. The devastating March 11 Japan earthquake and tsunami that took more than 25,000 lives are the most recent natural disaster that we've seen in horror. It occurred as if to defy the most advanced scientific understanding of how the Earth works. So were the New Zealand earthquake, Chilean earthquake, and Haiti earthquakes. Climate change, ocean acidification, sea level rise, and their effects on ecosystem and society are another sets that require good scientific understanding. And we just have, we cannot waste time to make a very good advance in science to understand how these are affecting our lives. And that's what I wanted to say.
Thank you very much, Kiyoshi. And if you would like to have a look at the current edition of the New Science Plan, you will find it under IODP.org. This new program, which will be called the International Ocean Discovery Program, the acronym remains IODP. You will find a folder here in your material. Will hopefully again be a cooperation between the US, Japan, and Europe, and some other countries. And as we are in Europe here, we thought it would be good to have a European perspective, a specific European perspective. And Catherine Mevel will talk about this. Please, Catherine.
Yeah, I will be very brief because I want to insist on the fact that the science is global, and European scientists, of course, want to look at the global system, so they want to be everywhere, I would say. So, but I want to insist on the fact that ECORD is bringing two perspectives to the new science plan at the scientific level. As I said, we have a global approach for the European scientists, but there are fields and areas of more specific interest, so I will insist on that. But also, we want to continue playing a major role at the operational level. And as Kiyoshi said, to the current phase of IODP, ECORD is bringing the mission-specific platform. This concept was developed during IODP, and it proved very successful. These platforms are contracted on a case-by-case basis to drill in areas which are inaccessible to the other drill ship, the Joy des Resolution and the CHIQ. And we have conducted 4 expeditions so far, and we hope to conduct one more before the end of the program. So we want to continue providing this opportunity to the international scientific community. Next slide. So coming now to more specific area that we want to investigate as European participation to the new program. One is the Arctic. And you know that the Arctic is a hot topic, if I can say so. We need to understand what is the tectonic evolution of the Arctic basin, because of course it has a strong impact on the climatic and environmental changes, not only of the Arctic itself, but of the whole global ocean. You know that there are gas hydrates which are trapped in the margins and which may be released into the atmosphere if the climate warms too much. So there are lots of issues to look at in the Arctic, and there are plenty of proposals already existing in the IODP system. So that's a scientific point, but it's also an operational point, because in the current organization of IODP, only ECORD can provide the platform to go to the Arctic with MSPs. We know how to do it. We did it successfully in the past, and we want to continue doing it. The second focus I would like to shed light on is the Mediterranean. The evolution of the Mediterranean Sea is of key importance to Europe. It records all the archives of environmental changes, and these archives are really necessary to fit the climate models. You may know also that the Mediterranean Sea completely dried up 5 to 6 million years ago, and 1 kilometer thick of salt was deposited. The salt is an extreme environment. It's a potential habitat for unique organisms, so that's something that people want to look at, and it has a connection with what Kiyoshi said about the deep biosphere. Salt has also the potential for lithium enrichment, and you all know that it's a strategic element. And the terrains beneath the salts are unknown, and there is a great potential for resources. But you all know, of course, also that the Mediterranean is the most tectonically active area in Europe. It's where the African and the European plate meet, so it's very active. And it has a long history of devastating geohazards. There are landslides, earthquakes, volcanic eruptions, which have triggered tsunami, and we know that they had a very important historical effect. So what we want to do is do exactly what Kiyoshi explained. We want to look at these active processes in the Mediterranean. We want to instrument drill hole for long-term monitoring because it is really key to understand active processes. And we want to link with other programs which are planning to install deep sea observatories. But just to remind you that we are in a global approach and we are interested in research on past climate, ocean acidification, El Nino events, because we want to better understand climate evolution. We are in Europe, there are a number of laboratories at the forefront of deep biosphere studies with potential application to biotechnologies. The role of fluid flows in Earth movement is also very important. And it's also important in the formation of resources like gas hydrates, metals, and so on. And of course, we want to be involved in the deep drilling into the mantle, this frontier science, because it will help us understand the fluxes between the Earth's interior and the atmosphere and how they have shaped our planet over millions of years. So this is a summary of how ECORD feel that they can contribute to IODP.
Thank you very much, Catherine. Before we open the floor for questions, I would give two informations. One is there is a town hall meeting tonight at 7 o'clock in room number 4. It's an IODP town hall, IODP ICDP town hall. There's a continental drilling program running as well. We are closely cooperating, so we have a common town hall meeting. And a film will premiere about ECORD, the ECORD expeditions of the past years. And you will find that on ecord.org, the website from, I think, tomorrow on. The other information is that if you would like to meet more scientists from the IODP community, you can come to our booth, which is number 57. There are a number of colleagues all the time, and if you look for information, please come to that booth. But now the floor is open for questions. I think there might be a few in the light of what the two colleagues said. Please.
Thanks. Richard Black from BBC. Got a question for Sayyidu-san. In the light of the earthquake and tsunami, I wonder how that changes things for Japan's involvement in IODP. I mean, I gather the ship itself suffered some damage. The government might be considering financial restraints. On the other hand, maybe it's been so devastating that people now want to put more money into this research.
As IODP, we are hoping for the latter, of course, and I think we are in the process of trying, the Japanese community is in the process of talking to the funding agencies that is the direction that should be taken, because Chikyu so far has been engaged in trying to understand the seismogenesis, not in that area where we saw the earthquake, but in the southwestern part of Japan, which also will experience magnitude 8 class earthquake in the decades to come. So we are quickly forming, as IODP, science team to quickly plan for studying the area where the March 11 earthquake struck.
When do you think that might be ready?
Excuse me, as we are web streaming this media conference, would you please use the microphone for the questions? Yeah. Thank you.
Could you just tell us when that actually might result in some drilling?
Within 1-2 year time.
Okay. So are there any more questions? All right, if this is not the case, then of course you're invited to make single appointments. I know that there is one. You would like to talk with Catherine, right? And you can make an appointment, of course. Then thank you very much for your attendance. I would like to invite you to come back to at least at 2 o'clock for the results of the Great Barrier Reef expedition. Thank you.